2 and
40,
20, 2 and 10.
2 and 5.
And then do you know, yeah, do you know what to do from here?
Yeah, you can take out the, so you can have these. Would you
Like,
take out 4 and then, or yeah, take out 4 and then square root
and
of yeah.
yeah, whatever's left over. So for each one, you bring
Yeah.
one out
Yeah. So then
and
it'd
then
be
you leave
2
one
times
in.
2, which is 4. So then it'd be 4 square root 5.
Right. Perfect. Yeah. And I mean, like, base, excuse me, your teacher's more likely to give you something like this, like the square root of 960. So do you want to try maybe working one out on your own and then we'll move on to something else?
Yeah.
How are you doing on this one?
Um, so I got 2 square root 5.
Well, for each pair though, for each pair you bring one out. This is a 9. Maybe that was unclear.
2 and
Yes, you bring out a 2 and a
got it. So
2
then
and a
it'd
2.
be this time, this time it'd be, it's gonna be 8 square root 15.
Yeah. So the good news is we're gonna get some more practice on these because we're gonna work on some other types of problems now with still with some numbers. Excuse me. All right. Let me know if you got that down or need any more clarification on that.
I think I got it.
Okay. So like where this moves to is you get a problem like this, the square root of 80 x squared y to the fourth power. All right. So this is really three problems. It's the square root of 80, the square root of x squared, and the square root of y to the fourth. Okay. So the square root of 80 you do just like you've been doing. 2 and 40, 2 and 20, 2 and 10, 2 and 5. This becomes 4 square root 5 again. Now, there's really a 2, I'll do that in red here. there's really a 2 above, each of these indexes. And the square root of x squared is kind of a special case. This becomes the absolute value of x. Okay, that's kind of thing one there. And that's a little weird at first, because a lot of times students just write x, but it's actually absolute value of x. Your teacher's going to emphasize that. This y to the fourth, we have to remember here that the square root of x is really x to the 1/2 power, because there's really a 1 there and a 2 there. It's really x to 1/2. So this y to the fourth is really y to the fourth to the 1/2 power. So that's where this is a little bit new. There's actually a couple other ways to look at it, but we'll do it this way for now. So when you have an exponent to an exponent, you multiply, and that becomes y squared. Okay. So a lot going on in this problem that's maybe different than the previous ones. Um, so there's parts without the root or with the root, without the root. So the simplification of this becomes 4 absolute value of x, y squared, square root of 5, which probably looks weird, but that is kind of the kind of problems it looks like you're looking at here. Any questions on that before we do another
One
example?
second, I'm looking through it. So first, you split it apart by the term, and then by it.
There's actually a number of ways to look at this,
Wait,
so
what
it's
if it
not
was x? What if it's 80x cubed y to the
right.
fourth?
So we're gonna do that next. We're gonna do that. We're gonna do that example next. So let's say it's square root of 500 x cubed y to the ninth. Okay. So it's really like three separate problems. It's the square root of 500 times the square root of x cubed times the square root of y to the ninth. Okay. So 500 here. The other way to do this, that is the more advanced way, is to figure out the largest perfect square that goes into this. I don't like this approach, but this is what your teacher might want you to do because you'll pick big ones. 100 is the largest perfect square that goes into this because so it becomes really the square root of 5 times the square root of 100, which is 10 square root 5. The disadvantage of this method is that you have to know the big perfect square that goes into it, and that could be hard to figure out.
Like for this,
But
this one is just 10 because 10 times 10
right,
is 100.
right, because it gets tiring to do, this tree here of 2 and 250, 2 and 125, and then you got to do 5 and 25. It can get messy. But that's up to you. Depends how much time you want to spend on these. And without seeing problems, I don't really know. Now, the square root of x cubed is really, let me make a little more, did I? It's really the square root of x squared times x, okay, which becomes the square root of x squared times the square root of x. Now, unlike the previous problem, it does not become the absolute value. So it's only when this number that's indexed matches this number in here, and it's even, that you get this absolute value. Okay, so it's not here because it's really x cubed. So this does just become x square root of x. And then this y to the ninth is really the square root of y to the eighth times y, which is the square root of y to the eighth times the square root of y, which is really y to the power of 4 times the square root of y. So your answers typically have stuff outside the root and then inside the root. And you gotta be able to, you know, mix it all together. So it's 10x y to the fourth, 5xy.
Oh God. So you have to break it apart kind of by the term, and then when you get the final
Yeah,
answer, kind of to put it all into one
yes.
answer with everything that's going outside of it on the
Right,
outside of it, and where and then everything's going
right,
inside.
right. So
Got it.
like, you do enough of these, you'll start noticing patterns. Like if it's even, it just like in the previous problem is even, you just, x squared becomes just x and y fourth becomes y squared. That's nice. When it's odd, you break it down to one that's 1 degree less, things like that. So
Got it.
any questions on this? Because I want to give you one to try basically like this, see what you come up with.
I think I get
Yeah.
it now.
Okay. So let's have you try the square root of 60 x to the seventh, y to the eighth, like that. Yeah, we'll have you try that. How are you doing on this one?
So Wait, I think I have it. Would it be 4xy square root of 15 x to the sixth y to the seventh?
Okay, so yeah, I think missed a couple things here. Let's just go through this one together here. I mean, it's that 4 squared 15 or 2 squared 15 is fine, but so this is the square root of 60. Let's just deal with that. It's 2 and 30, 2 and 15, 3 and 5. So there's a pair of twos, so that comes out.
Oh, I did. Yeah, I just put 6 and 10 to start off with,
Yeah, so
but
like, well, the problem is 6 is not a perfect square, and neither is 10. Like you'd have to know that 4, like if you knew that square root of 60 was 4 times 15, that's 2 square root of 15. That's the faster way. Now, the square root of x to the seventh, I was giving you one odd, one even, basically. So this is really the square root of x to the sixth times the square root of x to the one. And so the x to the sixth gets cut in half. This becomes x cubed square root of x. And then the square root of y to the eighth, because it's even, it just becomes y to
y
the
to the
fourth.
fourth.
And then, like you said, you pair up the stuff that's outside. So you got a 2x cubed y to the fourth square root of 15x. Okay, let's try another one here. Is that okay with you?
Yeah.
All right, let's go square root 48 x squared y to the fifth. That want to try, please.
All right, I got two absolute value of x, y squared, square root y.
Any other numbers inside there?
It,
Like 48's not a perfect square. Sorry. It's like 48 breaks apart into 2 and 24, 2 and 12,
oh,
2.
wait, yeah, I realized that. Yeah, it's supposed to be two absolute value x, y squared, square root, uh, 3y.
Okay. Yeah, you said y squared. I think I heard
Yeah,
2 though, but you bring two twos out.
yeah, I think I just missed one of the twos, or yeah, that's what I thought. Yeah, I think I just missed the other twos. Yeah, then it would have been four. Yeah.
Is that kind of okay? Um,
Yeah.
all right, so we're gonna move on to something slightly more difficult. Let's say I ask you to find like the cube root of I don't know, 600. Okay, so now you're looking for triplets. Like whereas before, you look for pairs, you could bring a pair, you could bring a number out with a pair. Now it's got to be a triplet. So 2 and 300, 2 and 150, 2 and 75, 3 and 25, 5 and 5. So there is a triplet here. So you bring the 2 out. But these other numbers, they stay inside. So it's 2 cube root of 3 times 5 times 5, which is 2 cube root of 75.
Got it. So if there's three of the same number, like if there's three twos, then you would take out two.
Yeah. And so like this is where I don't know how large numbers your teacher will try. You may not emphasize this much. I really don't know. Yeah, obviously I don't know. But like they can get really big. And yeah, I'm kind of hesitant here to give you one that's super large to try, but I kind of think that's worth doing here. Um, so let's have you try like the cube root of 1280.
All right.
Why don't you try that one? And then we can work it out together. How are you doing on this one?
Um, Trying to find the, oh, wait, how did you get 640?
You're just cutting it in
Oh,
half. Yeah, I mean, just yeah, you always start with two.
uh, the first two, yeah, okay.
So we didn't cover this, but you start with the prime
Right,
numbers. I mean, you generally don't have to go this deep into it to figure it out. Yeah, I don't know what your teacher will do, but
got it. I got those numbers, but I kind of trying to get like the, here, I got it.
so and I didn't really say this, but I should have. I just assumed you had known, but you keep trying the number until it doesn't work anymore, and
Got it.
that really really will help here. So um
Until you
you're
get
looking
a
for
prime
triplets
number,
now.
basically.
Yeah, you're searching for triplets, and then whatever's left over stays on the inside. So this time's a 2, and a 5 on the inside. So it's 4 cube root of 20.
Got it.
And okay. So we're gonna do the same thing though now with well actually we need to do another thing here. So cube roots, you can take the cube root of negatives now, which we haven't even thought to deal with, like the cube root of negative 108. This is really the cube root of -1 times the cube root of 108. This part is -1. So now you're just dealing with the positive. 2 and 54, 2 and 27, 3 and 9, 3 and 3. So this time it's got three threes. So a 3 is going to come out, but a 2 is going to stay in. So you got a negative on the outside, a 3 on the outside, and a 2 on the inside. So it becomes -3 cube root of 2. Yeah, take a look at that. See if you have any questions on that.
Yeah, I think I get it. So first take out the negative, then yep.
And it's just
Got
like
it.
one we just did. So here's one for you to try. Cube root of -56.
So would it be 2 cube root -7?
So the yeah, there's a negative on the outside. So this is the
Oh,
cube
so
root
you're
of
gonna
negative
go
one.
outside. Okay.
Yeah, so okay, my answer's gonna have a negative, is what you're saying. Yeah, like 2 and 28, 2 and 14, 2 and 7. So yeah, 2
One is
comes
a
out,
split.
7 stays in.
So then
So
it'd be
it's
-2 cube root.
yeah, like that. Okay. Let's try one more. Let's have you try this one. Cube root of -189.
I got -3 cube root 7.
Correct, yeah. And just be careful here. This three can often forget to do that, or you know you don't want to mix it up the index, the number there. Okay, good job on that. Now, we can also do things with variables. So let's say it's the cube root of a cubed, b to the fourth, c to the fifth. Okay, so this is really the cube root of a cubed times the cube root of b to the fourth times the cube root of c to the fifth. Now, when the number perfectly matches here, it's not absolute value. It's only if it's even, an even index and an even power, which you don't have here. This becomes just a. If you're wondering why, it's because it's really a cubed to the 1/3 power, exponent from exponent you multiply, so it just becomes a to the power of 1.
Got it.
Now the next one here is the cube root of b cubed times b to the 1, which is really the cube root of b cubed times the cube root of b to the 1. So this becomes b, and this is the cube root of b to the 1. C to the fifth here becomes the cube root of c cubed times c squared. Cube root of c cubed times the cube root of c squared. This becomes c. So now you have, again, parts inside and outside. So you've got an a b, and a c. Cube root of b to the power of 1, c to the power of 2. Does that make sense?
Yeah.
Okay, let's do another example before I suggest you do one here. Let's say it's the cube root of like b to the 10th, c to the 15th. All right, so again, it's really the cube root of b to the 10th times the cube root of c to the 15th. Now the c to the 15th, that's the nice one, right? Because it's really c to the 15th to the 1/3 power. So it's really c to the 5th. So if it divides perfectly, you just do it. Is that clear?
Yeah.
But this b to the 10th is really the cube root of b to the 9th times b to the 1, which is the cube root of b to the 9th times the cube root of b to the 1. So now the 9 and the 9 divisible by 3, so it becomes b cubed times the cube root of b to the 1. You have this c to the 5th here, so you have again part outside c to the cube, c to the 5th on the outside, cube root of b to the 1 on the inside.
Got it.
Okay, you ready to try one on your own?
Yeah.
Okay. All right, so here we go. We're gonna do the cube root 320 x to the 8th y to the 21st z to the power of 32. 31. Make that 31. How are you doing on this one? Looks like you might be muted.
Just saying them.
Do you need some more time on this or some questions?
I just need some more time.
Okay. Yeah, I think it's a bigger problem, but it's plenty doable.
All right, I think I got it. Would it be 2x to the fourth, y to the 10th, z to the 15th, square root or cube root 20yz?
Okay, so a couple things here, I think so you said just two on the outside?
Yeah, 2x
Okay.
fourth.
Okay, so yeah, that so I this one we're looking for threes though. It's a cube root. So um it's 2 and 20, 2 and 10, 2 and 5. So it ends up that there's two pairs of threes, two triplets like that.
Oh, right.
And there's a 5 on the inside. Now the bigger, that's okay. I mean, well, no big deal. The bigger issue is that I think you thought this was a 2, so you thought, okay, I'm gonna cut that in half. Um, it's really x to the eighth is really the cube root of x to the sixth times the cube root of x squared. So it's the x to the sixth that gets divided by 2 or divided by 3 to give you x squared. And then the cube root of y to the 21, that's the one that works out nice. So that just becomes y to the seventh because you can divide it by 3. The cube root of z to the 31, you can treat this as the cube root of z to the 30th times the cube root of z to the 1. And that becomes the cube root of z to the, well, that first one becomes z to the 10th. All right, so kind of a lot there. So there's a 2 and a 2 on the outside, an x squared, a y to the 7th, a z to the 10th, and then the cube root of there's a 5, there's an x squared, and a z to the power of 1. And that's kind of like, that's kind of a bigger problem here. So it does become 4 there. So I think you just thought it was a 2, and then you start cutting stuff in half, Um, that definitely don't want to do that. So these are the harder ones, and they go from here. Like I was maybe gonna do one with a 4th power or 5th power, 5th root. We'll see if you want to do that, tomorrow night, or if you got some other stuff. Did your teacher post anything for you
So
guys over the
far she
break?
didn't post anything. Right now I'm just going
Okay.
off of the